Okay, today's lesson is 2-4a, zeros of polynomial functions. Part A is concentrating on the real zeros of functions. Part B will concentrate on the complex zeros. So, to start off with, real zeros are either those that are rational or irrational. The rational ones are the ones that are integers as you know them, or fractions. A rational number is any number that can be written as a ratio of two integers. Okay, it's also a decimal that terminates or repeats. Okay, irrational zeros are going to be those that include radicals. If you notice this problem, square root of 5 is not a perfect square, so when you take the square root of it, you get an irrational number. You also can have any decimal that doesn't terminate or repeat. Okay, so the first thing we have is something called the rational zero theorem. You might have heard of it previously as the rational root theorem, and it basically describes how the leading coefficient and the constant term of a polynomial with integer coefficients can be used to determine the list of all possible rational zeros. Okay, and this is that theorem, y'all, that says we can take the factors of our constant term and put them over the factors of our leading term and get all the possible rational zeros. Okay, it's often referred to, well, the constant term. The factors of the constant term are given the letter P. Factors of the leading coefficient are Q. So if you think of going this way all the time, it's that thing that people go, oh, is that P over Q thing? That's what this is, the P over Q thing, what people refer to it. Okay, so look at what you've got to be able to do. Have a leading coefficient equal to 1 in this case. We are going to list all the possible rational zeros, and I'll label that as PRZ, so I don't write all that out. And then we're going to determine which, if any of those, are zeros of our function. So 1a, I have f of x equal to x cubed plus 5x squared minus 4x minus 2. So my possible rational zeros are going to be always 2 over whatever that number is, which is 1. So really, if my leading coefficient is 1, I only have to worry about that number. So what are the factors of 2? Plus or minus 1, plus or minus 2. You always, always, always have to think about the positive and the negative factors. Okay, so because there's only 4 of them, I'm just going to start with the number 1. And so I set up my synthetic division. I'm going to write my coefficients. All right, and I'm going to look and go cubed squared to the first degree 0, so I don't need any 0 placeholders in that. And then I'm going to start my dividing. So I bring down my 1. 1 times 1 is 1. 5 plus 1. 6 times 1. 6 and negative 4. 2 times 1. And we hit the jackpot on the first one. That was nice. So that means what I started with, y'all, this is the other thing, remember in synthetic division, you want to remember what degree you started with, and you always go down by 1, so that's a second degree, and that gives us this polynomial, x squared plus 6x plus 2, because the answer that we get from our synthetic division, those are the coefficients of a second degree polynomial. Now, you can go graph it, you can go see there are no factors of 2 that add up to give me 6. So I actually know that I'm done here, and I have all my rational zeros. The only one I have is 1, because there's no way that negative 1 plus or minus 2 are going to factor into that. So that's all we had to do for that one. All right, look at 1b. I have h of x equals x to the 4th plus 3x cubed minus 7x squared plus 9x minus 30. So if you can figure that out, again, our leading coefficient is 1, so I only have to worry about these, but that's still a lot of factors. So how many exactly do we have? That many. Okay, when I'm listing them, I go 1 goes into it, 2 goes into it, 3 goes into it, 4 does not, 5 goes into it, oh, then it's 5 times 6, and so then I'm finding the pair for each one. Now, there are tricks that we used to use before we had these nice calculators of knowing where to start. And that's one of the things that we've taken out of this lesson, because most of y'all have a scientific calculator that has a graph or a table on it. So I will show you how to use your table feature when you see me, or you can email me. But if not, then what I use is ClassCalc. So I probably should go in and show you how to do that, but I'm going to go ahead and put the table. You basically want to look at a graph or a table, but most times you're not going to have that graph accessible to you. So we would use a table. And I'm going to go ahead and show you that table in ClassCalc. So what I did is, I had to pause to get that ready for you. Whoopsie. So in ClassCalc, all right, my polynomial, we're going to type it in up here. I'm on the graphing tab, y'all. Not scientific, not matrix. Ooh, that's new. Okay, on the graphing tab. So I'm going to type in y equals x to the fourth. Come down from that, plus 3x cubed. Come down from that, minus 7x squared. Come down from that, plus 9x minus 30. Now, I have the graph, but I'm going to act like I don't have that graph. And if you long press on that, then I'm going to duplicate it. And then when I come here, long press again, and I'm going to convert it to a table. And you don't have to duplicate it. I do, because then I get to still see the graph. So what I want to point out to you is you can put whatever numbers that you want to in here. The numbers that we had, 1, 2, 3, 5, and 6. So I'm going to start at -6, and then I'll worry about those later, because I'm going to hope it's something between there. So if I backspace and type -6, enter, -5, enter, -4, enter, -3, enter, -2, okay? And then you can keep going, but as you see, I have 2 zeros right here, okay? And even though I didn't need number 4, -4 on there, because it was not, remember, it wasn't in my list here, so I didn't need it. But sometimes when you get harder ones where you want to look and see if there's a sign change, it lets you know if the fractions are in between there. So that's the only reason I did that, okay? So back to our problem, I have copied the table and put it right here for us. And we just saw that we have a 0 at 5 and a 0 at 2. So I'm looking for zeros in the y column, and what I see in the x column is going to be my 0. Now, you can start with either one. I choose to start with 2 because it's a positive number, and people just make fewer mistakes with a positive number. So I put my 2 in. I'm going to set up my, write my coefficients, and I can look at them and see that I'm not missing any of my exponents. They go 4, 3, 2, 1, 0. Now, something a little bit different. Back over here, I didn't know if 1 was a 0, so I went straight into the synthetic division. Here, I know that 2 is a 0, so this is what we got from our remainder theorem, okay? And therefore, since 2 is a 0, I know that I'm going to have a 0 right here. So this is kind of the way I start it when I find a 0. And that means that this number has to be positive 30. And I just do that because it helps you stay focused on what you're doing. So I'm going to go back to the beginning. I'm going to carry down my 1. 1 times 2, 3 plus 2, 2 times 5, -7 plus 10, 2 times 3, and 9 plus 6. And 2 times 15 is positive 30. So I know I've done my math correctly. Because sometimes when you get down there, like I said, some people get lost, and this is a multi-step problem. Okay, so this is the other thing that's really, really important. Okay, so the next 0 that I'm going to use is -5, and I do not want to start over with this one, because the whole point is I'm trying to reduce this down to a quadratic, because I know lots of methods of solving quadratics. So I'm going to use what I referred to earlier as your reduced polynomial or depressed polynomial. And this time I'm going to use -5. So I've got my synthetic division set up. Again, I know it's a 0. So I'm going to put 0 here, which means this has to be -15. So carry down my 1. -5 times 1. -5 plus 5. -5 times 0. 3 plus 0. And -5 times 3 is -15. So we're good to go. Okay, so remember, I started with a 4th degree. That means the first one down is a 3rd degree, and the next one down is a 2nd degree. And so now I have a quadratic equation with the coefficients of 1, or a equal to 1, and c equal to 3, because b is 0. We solved that by subtracting 3. And then I'm going to take the square root of both sides. Remember, because there's a negative there, okay, in front of my 3, when I take the square root of that, that's why I have an I in my answer. Okay, so the real key, y'all, in our directions, determine which, if any, are zeros. Well, this is clearly not in this list of rational zeros. So the only rational zeros that I have are -5 and 2. Okay, so those were problems where we had our leading coefficient equal to 1. Now we're going to look at some problems where our leading coefficient is not equal to 1. Okay, so I have the same directions, y'all. List all the possible rational zeros of each function, then determine which, if any, are zeros. So 2a says g of x equals 2x cubed minus 4x squared plus 18x minus 36. Okay, this is where, to me, the visual helps. I'm putting the factors of 36 over the factors of 2. So the factors of 36 are in the top, the factors of 2 are in the bottom. So when I list those, y'all, I have to put each of these numbers over 1 and then each of those numbers over 2. So first off, I'm going to put them over 1, which means I'm listing them all out like that. Those are the numbers that I have up top there, plus or minus. And I put plus or minus in front of each of them because when you put your answers into DeltaMath, that's the way you'll have to do it. So now when you put them over 2, I put 1 over 2. I got plus or minus 1/2. 2 over 2 is 1. 3 over 2 needs to be in my list. 4 over 2 is 2. 6 over 2 is 3. 9 over 2 needs to be in my list. And the others, 12 over 2 is 6, 18 over 2 is 9, and 36 over 2 is 18. So those are all my possible rational zeros. Again, we don't need the tricks because we can go look at the table. So I go grab my table, and I just picked some, hoping I would get one in there, okay? You can put the numbers in however you want, because like I said, if you're on a scientific calculator, you have to scroll up and down your table to find the zeros. In class calc, you can just put those numbers straight in there and see. So I have 2, so I'm going to start with 2. And I'm going to write my coefficients and double check 3, 2, 1, 0. I don't need a 0 placeholder. I know it's a 0, so I'm going to put my 0 here first and know that that has to be 36 when I get there. So bring down my 2. 2 times 2 is 4. -4 and 4 is 0. 2 times 0 is 0. 18 plus 0 is 18. And 2 times 18 is positive 36. So I'm good. Okay. And this is my 3rd degree, so this is my 2nd degree, which means I'm ready to go alone and solve it as a quadratic, especially with that 0 in there, kind of makes it easy. So I'm going to subtract 18, and then I'm going to divide by 2. And when I take the square root, because x squared equals a negative number, squared can't equal a negative number, then again I'm left with an I in my answer, plus or minus 3i. So my rational zeros, in this case, the only one I have is 2. And that's all we got because we found them all. Okay, I forgot to point that out in the beginning. All right, next one, 2b says f of x equals 3x to the 4th minus 18x cubed plus 2x minus 21. So again, I'm going to put the factors of 21 over the factors of 3. The factors of 21 are 1, 3, 7, and 21. Factors of 3 are 1 and 3. So my possible rational zeros, I'm going to list all those that go over 1, plus or minus 1, 3, 7, and 21. 21 must be down here. And then I'm going to put them over 3. So 1 over 3. 3 over 3 is already in there. It's 1. 7 over 3 and 21 over 3 is already there. So those are my possible rational zeros. Which of these are roots? Okay, so this time I went into class calc and I only put the factors. Okay, so -21, you can see that these are all the whole numbers first, and then I put the fractions. So that's the nice thing about class calc, is you can just put them in any order that you want. I do not have a 0 anywhere in here. Okay, and since I have no zeros out of this list, then I have no rational zeros. Okay, because so what we've been doing, y'all, every 0 that we've talked about, rational or irrational, okay, but has to cross the x-axis. Okay, so you would see it on a graph. If it is a real zero. Okay, in the next lesson, we're going to talk about complex zeros. But before we do that, I want to show you a few of the problems that you're going to be doing in DeltaMath. So make sure you don't have any trouble with them. So as I just said, so these two problems here in your homework are just like the P over Q. You're just listing them. Okay, but here to kind of help us get prepared for the next one, I want to point out to you what you're going to have. Mine does this sometimes. I don't know if y'all's does, where it doesn't complete the whole graph. But as I said, if it's a real zero, it has to cross the x-axis. So to do this, I'm looking at the fact that 6. If 6 is a 0, then that means x minus 6 is the factor. So that means I don't have to look at these. So it's one of these two. And so the other one is going to be, x squared equals 12. So x equals plus or minus the square root of 12 or plus or minus the square root of 5. Okay, this number is in between 3 and 4. I happen to know the square root of 5 is 2.2, so it has to be the square root of 12. So that is my answer. All right, let me do one more for you. So see again my graph if I get it wrong. Okay, so I have plus or minus 1. And plus or minus 1, which was similar, y'all, when you have the same numbers but opposites, it's going to be like that one I just did where it said x squared minus something. So I need x squared minus 1. So it's just one of these two here. And then I have negative 7. So does this give me negative 7 or does that give me negative 7? And if this, okay, these are zeros of our graph. So if you set that equal to 0, x plus 7 equals 0, then x equals negative 7. So this is my root. So this is all you have to do is kind of just warming you up so that if you see the roots, you know what to write for the equation. Okay? Now, on level 3, okay, you have to remember what the multiplicity does. Okay? So in the multiplicity, okay, it changes whether you have an odd or an even multiplicity. So first off, I'm going to look at this and say that's 3, which gives me the factor of x minus 3, which means it's one of these two here. Okay? And then I look here, and that's x plus 4. Well, they both say x plus 4. So now what's the difference in these two? These are both squared because the squared makes it act like a quadratic. And so it's going to be like a parabola. So that's that. Is my 3 supposed to be squared? It's squared here, but that root doesn't look like this one. It doesn't behave like a parabola. It goes straight through. So there's no squared on it, and this is going to be your answer. All right, I'm going to do one more of those just to make sure. Oh, good, it came out this time. So this one, I have negative 2 and 4, okay? Again, that means that I'm going to have a squared on my, as an exponent on my factor, okay? Minus 2 means my root is x plus 2, so it's one of these two here. And then 4, again, should have a square on it, so it's not going to be this one, it's going to be that one. And that's all you have to do for these, so I hope you think that's pretty easy, okay? And I think I was going to show you the last one for this video. Write a polynomial from the graph, okay? So here it is, but something a little different about these that you didn't have to worry about on the last ones, okay? And I'm going to show you, I'll show you what happens if you don't pay attention to this. So this has a root of x, it's negative 5. Well, it went away on me, but we know what it was. So that's x plus 5, and it was a parabola, so I know it's going to be squared. I'm going to come back down. And then I have that one, which I don't know, was it x minus 5? Let's just try x minus 5 because I get, I'm at attempt at 2 out of 2. So that's because I came in here and did it earlier. So I'm going to miss this one. Nope, hold on. Shift. Okay. That's because I went in and did it, so I should have done another one. But it's going to be wrong because you've got to pay attention to this right here, which is your y-intercept. Okay, so I'm going to go back over to a spot that I can show you. Let me see if I got some room up here. Okay, so what we had there, y'all, was I had y equals x plus 5 squared and x minus 5 squared. Okay, now to help you understand that there's actually an a value on there that stretches it, and I have a point on here of 0, negative 400. That is on my graph. 0, negative 400. Okay, So if I put 0 in for x here, y'all, 0, that's going to give me 25. And if I put 0 in here, that's going to give me 25. And 25 times 25 doesn't equal 400. So what you actually have to think about is there's really an a value here that affects the stretch, the vertical stretch of your graph. So if I were to plug those numbers in, okay, if I plug this into my equation, I'm going to have negative 400 equals a, and I don't know if y'all know 25 times 25 happens to be 625. Okay, so I'm going to divide both sides by 625, and negative 400 divided by 625 is equal to negative 0.64. So when I go back and put this in, I actually have to go put a negative 0.64 in front of that. And let's hope that was right. It's not. Oh, you know why? No. What did I do wrong? Oh, it didn't get it, y'all. I couldn't see the graph correctly. Okay, I couldn't see the graph correctly. Let's do one. Because, see, this is what happened to me before, y'all. I couldn't see the graph. So if you see that, I had to submit my answer like that because then it showed me the graph. So I hope y'all don't have that trouble. All right, so that's negative 5 and negative 1 and negative 25. So I'm going to try that one more time. Negative 5. So I had basically y equals a times negative 5, which is plus 5, and negative 1, which is plus 1, and they were both squared, and I think I had the point 0, negative 25. Let me go back to that graph real quick and look. Negative 1, negative 5, and I had 0, negative 25. Okay, I don't want to push that yet. All right, so I'm going to go put those in. So this is negative 25. Don't know what a is. If I put 0 in, that's 25. If I put 1 in, that's 1. Okay, because 1 squared is 1. So 25 divided by 25 is 1. So a should be negative 1. In this case, all I have to do is put a negative sign in front of it. So let's go see if that works. And if it doesn't, I will see my graph. I hope y'all don't have this trouble. So that was x plus 5. Oh, I didn't square it. Shift squared, come back down. X plus 1, shift squared. Oh, poo, I didn't shift. Shift squared. Okay. So, is that what I have? X plus 5, x plus 1, quantity squared. And we're good to go. Hope that helps. Hope that helps you get through your homework quickly. Thank you so much. Y'all have a great day. Don't hesitate to email or come see us if you have any questions. Thank you.